Hello, myself Vedanta.
Hello, myself Yashai.
Myself Joel Joy.
Hi, this is Prashant.
Now I'm going to explain the project in which we have implemented Deadlock. Now I'm going to explain what actually Deadlock is. It is a state where two or more operations are waiting for each other. Say a computing action A is waiting for action B to complete while B is waiting. B can only execute when A complete his work or complete his action. Deadlock is a common problem in multiprocessing system, parallel processing, and distributed system. The deadlock condition actually occurs in OS when a process or thread enters a waiting state because a requested thread enters a waiting state because a requested system resource which is held by another waiting process, which in turn is waiting for another resource held by another waiting process.
I am going to explain about banker algorithm. Banker algorithm is also called as avoidance algorithm. It is developed by either discussed. It is mainly used in banking system to ensure that bank does not run out of money when a new process enter system and declare the maximum number of instance resource type that needs. The number may not exceed total number of resource in system. User requests a resource. The system must determine the allocation of resource will leave the system in a safe state. If the resource are allocated. The process must wait until some other process relief. For implementing the banker algorithm, we have to know about several data structure which is used in implementing the banker algorithm, that is maximum allocation available needs, and the rest of the programming codes is implementing programming codes of the banker algorithm is explained by Joel Joy.
I'm going to explain the program of Banker's algorithm. That is the implementation of Banker's algorithm in C++. I'll show you the program. This is the program. That is the first line hash include IOStream. The second line hash include conio.h. Both are the call for the compiler to call the header file which contains input and output functions, and this is for calling the system using the system functions like system pause, system clear screen example. Using namespace std is for using the standard functions, and the main function is of return type integer. The variables all are declared over here. Then the user is asked to enter the number of resources. Among this variable, the main are allocation matrix, that is two-dimensional array, then an available array of size 5, then need two-dimensional array, that is its name need. Its size is 10 cross 5. It's for need matrix. Then this is count of resource, and this is count of process, and this is a array called running. It does size 10. Then I ask the user to enter the number of resources he or she has in the system. It's preferably if the user enters less than or equal to 5, it's fine, otherwise also it's okay. It's stored in count of resource variable. Then the maximum instances of the resource uh, should be entered by the user. It is asked to the user using the cout statement, and it is repeatedly asked to the user for each resource, that is R0, R1, like that. Example, this is made into implementation using a for loop. Then this available, this, that is the values given by the user is stored in the instance array, and this instance array is copied into the available array. It will become the available, the number of available, no, the available resources can be found in this available array. Then the user is asked to enter the number of processes. It can be 5, 3, anywhere. It can be even more than 10, but it will be proper if it is less than or equal to 10. It will be stored in count of process variable, that is in short count of p, using the scene statement, and using the cout statement, the enter the number of processes displayed. Then the user is asked to enter the allocation matrix using the cout statement, and for each process the user has to enter the resource that has been allocated to the process, and the allocation of resource also should be entered by the user. All these things are done using two for loops, and it is stored in allocation matrix, a two-dimensional array. Then the allocation matrix is copied to the available array. It is the value in allocation matrix is assigned to the available array. Then the user is asked to enter the max matrix, that is the maximum resources needed for the process to complete the execution. So it is displayed using the cout statement for the process P, for example P0, P1, P2, P3, goes on. Endl function is used to go to a new line, or to end the line. A for loop is used to again and again ask the user to enter the maximum maximum needed resources. It's stored in a max array. It is a two-dimensional array, or it also can be called as a matrix. Then the given data can be displayed using cout statement, and the total resources in the system is displayed using the cout statement, and the array the instance array has the total number of resources, so it is displayed using the cout statement. This for loops will run until count of resource as less I should be less than count of resource. Then the allocation matrix also similarly it's displayed. The allocation matrix is stored in a two-dimensional array whose name is allocation, and it also has two for loops. It also runs until this for loop runs until count of resources less than j. J should be less than count of resource, and here j should be less than count of resource, and here count of I should be less than count of process. Then the maximum max matrix, or the maximum resource needed for the process to complete its execution, is displayed using the cout statement and 2 to 3 for loops. It is there the values are available in max array. It is a two-dimensional array, also called as a matrix. Endl is used to go to a new line. Then two for loops are used to copy the to find the needed resources. The number of needed resources are calculated by subtracting allocation matrix from the max matrix, that is allocated resources is subtracted from the maximum needed resources. Then the need matrix is displayed using for loops and cout statements. Enter is used to go to a new line. Now to check whether above state is safe, sequence in which above requests can be fulfilled, and press this is displayed using the cout statement, and get ch function is used so that whenever the user gives a character or presses any key, then only the rest of the statements will be executed. So count will be assigned count of p, that is count of process I, and this for loop is there. This is to check the banker's algorithm. Here we have a while loop. If count returns if the count values if it is 5 processes, count of processes will be 5. So this count will be 5, and so the loop runs for 5 times. Safe is initialized to 0, it is for safe state, and then count of process is count of p. Then if running array returns a value 0, then this doesn't get executed, otherwise it gets executed. If it returns 1, then completed is equal to 1, so the process is it denotes that the process is completed. Otherwise, if need matrix is greater than available resources, then completed is initialized as 0. That means the process cannot be completed using the available resources. That is, it goes to an unsafe state. If it is completed, then the running array is initialized to 0, and the count is decremented. Safe also is initialized to 1 because it is in safe state now, because the process can complete its execution using the available resources. Then the sequence in which the processes can be executed in the processor can be displayed using this for loop, and here we have available array allocation matrix. Available array will be assigned as available array plus this allocation matrix. Value will be assigned to the available array, and sequence array will be storing the value of I. See here, I is there. It will tell us a sequence in which the processes will get executed in the processor. Then using the cout statement, we can display the running process, and the total resources now available can also be displayed using these for loops, and the safe sequence also can be displayed. Break is used to come out of the loop, and the available array can display the available resources, and if it is in safe state, then it can the control comes out of the loop. Otherwise, if it is not safe, it comes out of the loop. Otherwise, if it is in safe state, the system is in safe state, so it is displayed using the cout statement, and the safe sequence is displayed using this for loop. Here count of I should be less than count of process, so all the processes will be displayed in safe sequence. Otherwise, if the system is in unsafe state, then it will be displayed as the system is in unsafe state. Get ch function is used to get a character from the user, or else if user types a character, then only the program returns, or the program returns, the main function returns. Thank you. Now next, the output of this program will be displayed and explained by Prashant. Thank you.
Now I'm going to build the program. There is no error. Now I'm going to compile a program, that is, I'm going to get output. Enter the number of resources less than or equal to 5 is 3, and enter the maximum instance of resource 0 is equal to 10. enter the maximum instance of resource 1 is equal to 5, and enter the maximum instance of resource 2 is equal to 7, and enter the maximum number of process which is less than or equal to 10 is 5. And for the now I'm going to enter the allocation matrix for the process P0, that is the allocation of resource 0 is 0, and the allocation of resource R1 is 1, and the allocation of resource R2 is 0. Hence for the process P1, the allocation of resource 0 is 2, and the allocation of resource 1 is 0, and the allocation of resource 2 is 0. And again for the process P2, the allocation of resource 0 is 3, and the allocation of resource 1 is 0, and allocation of resource 2 is 2, and again for the process P3, the allocation of resource 0 is 2, and the allocation of resource 1 is 1, and the allocation of resource R2 is 1. And for the process P4, the allocation resource of 0 is 0, and the allocation of resource R1 is 0, and the allocation of resource R2 is 2. And for the enter the maximum matrix for the process 0, the maximum demand of resource 0 is 7, and the maximum demand of resource R1 is 5, and maximum demand of resource R2 is 3, and for the process 1, maximum demand of resource 0 is 3, and the maximum demand of resource 1 is 2, and the maximum demand of resource R2 is 2. And again for the process P2, the maximum demand of resource 0 is 9, and the maximum demand of resource 1 is 0, and the maximum demand of resource 2 is 0. And for the process P3, maximum demand of resource 0 is 2, and the maximum demand of resource R1 is 2, and the maximum demand of resource 2 is 2. And at last for the process 4, the maximum demand of resource is 4, and the maximum demand of resource 1 is 3, and the maximum demand of resource 2 is 3. Hence this is the maximum matrix for process 0, 1, 2, 3, 4, and this is a value for resource 0, 1 and 2, and this is a need matrix for process 0, 1, 2, 3 and 4. Now I am going to check whether the above state is safe sequence in which the above request can be fulfilled. Now the total resource now available of resource 0 is 7, resource 1 is 5, and resource 2 is 3, and the running process of is process 2. This is for process 0, this is for process 2, and this is for process 4, and the total resource now available for resource 0, 1 and 2. Hence the system in its safe state. Hence the safe sequence is process P1, P3, P4, P3, P4 is return. Now again I am going to build the program and I am going to run. Now I am going to, the deadlock is showing whether this is, now I am going to show the deadlock is in safe state. The system is in safe state, unsafe state. enter the number of resources which is less than or equal to 5 is 2, and enter the maximum instance of resource 0 is 2, enter the maximum instance of resource 1 is 2, and enter the number of process is less than or equal to 10 is 3, and enter the allocation matrix for the process 0 is, the allocation of resource 0 is 2, and the allocation of resource 1 is 2, the allocation of for the process 1, the allocation of resource 0 is 1, and the allocation of resource 1 is 3. For the process 2, allocation of resource 0 is, I'm giving 2, and the allocation of resource 1 is 1, and now I'm going to enter the maximum matrix for the process 0, that is the maximum demand of resource 0 is 3, and the maximum demand for resource 1 is 3, and for the process P1, maximum demand of resource 0 is 3, and the maximum demand of resource 1 is 3, and for the process P2, the maximum demand of resource 0 is 2, and the maximum demand of resource 1 is 3, and hence the given data are that resource in the system is for 0 is 2 and for 1 is 2, and the allocation matrix for process 0, 1, 2 are given, and the maximum matrix for process 0, 1, 2 are also given, and the need matrix for process 0, 1, 2 are given. Now to check whether the above state is safe or sequence in which the above request can be fulfilled. Hence I have already told this is unsafe state, so the system is in unsafe state. It's written. Thank you.